Good everyone. Today I am going to have you people on a topic called position and what? Distance. These are the two topics I'm going to treat today. Now we start with the first one, position. Now when we say position of an object, what do we actually mean? We are talking about, in physics, the position of an object is where that object is found or located. Now for we to locate the position of an object in physics, it depends on two factors. One, we are talking about what we call a reference point or origin. Then the second one is what? Axis. So in the axis, we have two axes here to discuss. One is what? X axis. The other one is what? Y axis. Now, for we to know the position of an object, we can locate the position of an object graphically by using what we call Cartesian method. In this Cartesian method, here is what? Y axis. And here is what? S axis, positive S axis. Here is positive Y axis. Down here is what? Negative Y axis. And here is what? Negative S axis. This particular point is our origin, which is 0, 0. Now in that case, suppose that what? An object is found at this particular point. And that point is what? A. When you trace down this particular point to this S axis, you can see from the reference point, from the origin to this particular point is what? Our X. It's very, very important. Now from here to here is what? Our Y. Now meaning that what? For we to know the position of this particular object at the point of A, we must define our X and Y axis. Very, very important. Now, which means to get the position of an object, this particular axis is very, very important from the origin. Now, secondly, suppose that this object moved from A to B. Let me just say the object has shifted from this particular point to this particular point. Let me call B. What do we have? We can say that initially the object is located at this point. Let me call it S1. The first point we can see the object. This is at A. And at A, we have S1 and Y1. Meaning that the first position of the object on the X and the first position of the object on the Y will give us the position of this particular object at this point. Now, when the object has shifted to this particular point, what are we going to have? You can see, tracing this man here, this particular point down to X. S has shifted to this particular point to this particular point. Now, Y, you can see, has shifted from this particular point to this particular point. There is always change in the position of the object, and also change in the position of the object. So the X axis, the object has shifted from S1 to S2. In the Y axis, the object has shifted from Y1 to Y2. Therefore, measuring from here to here, what can we see? The object has occupied a distance. What is the distance? By shifting from one position to another position. Here is our S2 and Y2. So you can see, for distance to occur, object must shift from one position to another position. The object has shifted from the position of S1 to position of S2. Even from the position of Y1 to the position of Y2. So there is always a change in the Y side, a change in S side. So you can see, for me to measure the distance from here to here, what do? We are going to record this side and this side. Now, from here, look at, from here to here is equal to from here to here. So if from here to here is what? Change in what? S-axis. Here is going to be what? Change in what? S-axis. If from here to here is change in y-axis, look at the properties of this shape. We are going to see that what? Whatever we have here is also the same thing as we have here. Here is what? Change in y. Then look at this. There is a shape we are seeing there. Whatever we have this side is equal to this side. So in that case, I can bring out what? The triangle. When you bring out the triangle, what we have here is what? Change in what? Y. And what we have here is what? Change in what? X. Moving from here, the object moving from point A to point B has occupied from A to what? B has occupied what? A distance. So in that distance, what can we say? How do we measure the distance of the object? You can see this is what? A right angle triangle. Being a right angle triangle, when these two sides are known, we are meant to find this particular what? Side. What do? We are going to apply a Pythagoras rule. What is that Pythagoras rule? The hypotenuse what? Square is equal to what? Opposite square plus what? Adjacent square. Now, the hypotenuse is the side the right angle is what? Facing. So this right angle is what? Facing this side. What can we say? Here is what? Our hypotenuse. Here can be our opposite if angle is here, and here can also be our opposite if angle is what? Placed here. So if I name here opposite, here is going to be what? Adjacent. Why? I can choose any side to be what? Opposite, because there is what? No angle. So in that case, what can I say? Using this Pythagoras rule, our hypotenuse is what? D. Our D, we have square, so here is what? Square, equal to our opposite is what? Change in what? Y, all square, plus our adjacent is what? Change in what? SA square, because there is what? Square here. So in this case, our D square is equal to change in Y square plus what? Change in what? SA square. Now, how can I get the distance? The distance is equal to the square root of what? Change in y square plus what? Change in what? S square. Now, our d is equal to square root of, because of 2 plus what? 3 is equal to 5. And 3 plus what? 2 is equal to 5. In addition, even if you change the word, the element, the numbers, we are getting what? The same answer, because of the law of what? Commutative. So in that case, I can say change in s square plus what? Change in what? Y square will still give me the same thing as this when I change the two what? Variables. Now, if distance is what? This, what do you know about what? Changing x? Now, supposing we are talking about what? Changing s, which is from here to here. From the reference point, we check a distance from here to here as S1. Then distance from here to here as S2. You can see that what? S2 is bigger than what? S1. So if I want to know this little distance, it means from here to here, which is our S2, minus from here to here, which is our S1, so that this one plus this one will give me what? S2. So I can say from this word diagram, we can see from here to here is our S1, plus from here to here is our change in what? S. Then from here to here is equal to what? Our S2. So how can I get our change in what? X. Our change in S is equal to what? S2 minus what? S1. Then this is for S axis. For Y axis, from here to here, from the origin to this is our Y1. So I can have Y1 plus from here to here is our change in Y. So from here to here and from here to here will give me from here to here. And from here to here is what? Our Y2. So what are we going to say? Our change in Y from here is equal to y2 minus what? y1. So because of this, we go back to what? Our distance, which is equal to square root of, what is this? Change in s. What is change in s? Our change in s is given as what? S2 minus what? S1. This is our change in s, which is this. And this change in s is having square. So everything about this one is what? Squared. Plus, what is our change in y? Our change in y is y2 minus y1. We are going to have what? Squared. So whenever we are asked to find the distance of what? Of an object moving from one position to another position, the distance of such object is what? Calculated using what? This formula. But whenever they say we should trace, look at a question. Look at this. Trace the position of A equal to 2 and minus 3. Remember, the first one is S as is, second one is what? Y as is. To trace this position, we use Cartesian what? Graph. In Cartesian graph, here is what? Y as is positive. Here is what? Negative Y as is. Here is what? Positive what? S as is. And here is what? Negative what? S as is. This is our origin. So you can see our S is what? Plus 2. So I can say maybe here is what? 1 and here is what? 2. We have 3 and so on. You can see that what? Our S is what? At plus 2. Then our Y is what? At minus side. So here is what? Minus 1, minus 2, minus 3. So we can see it as what? Minus 3. When I trace this one and trace this one to see where both of them are going to meet, we are going to see that what? Their intersection is what? At this point. And that point is what? Where we have 2, what? Minus 3. This is the position of what? These 2 points. Now, if I have question number 2, trace the word position or location of what? Of P equal to minus 1 and minus 3 and the minus 2. How can we trace it? You can see this is what? Your positive Y. This is our negative Y. This is our positive S. This is our negative S. This is the origin. Being the origin, this is our negative X. So we can find it in what? Negative side. And this is what? Our negative Y. We can find it what? In negative side. So this is where both of them are going to meet. So when they meet there, we are going to call it what? Our P minus 1 and what? Minus 2. So to trace the position depends on the what? S and what? Y. Now suppose the question says, find the distance of a body that moved from A minus 2, minus 3 to what? B, which is what? 4, what? 5 or 4, let me just say 8. To find this distance, what we do is a question. A body that has moved from where? From A to what? B. First of all, let us what? Trace it. Let us trace it. In the tracing, we have positive Y. Here is negative Y. Positive S. Here is what? Negative S. This is our origin. What do we have here? This is S1, Y1. Initial position of the what? The body. So this is what? S2, Y2. Because the body has changed its position, moving from what? A to what? B. Now, in the first position, we have what? Minus of what? X. So if I call here minus 1, minus 2, minus 3. Where we can see it is what? At minus what? 2. And this is what? Minus 3. So this is minus 1, minus 2, minus 3, minus 4. So we can see this one at what? Minus what? 3. Where can both of them meet? When you trace this one like this and like this is where we are going to see them meeting. So at that particular point is where we have A equal to minus 2 and what? Minus 3. Now coming to the other one, B. What is our B? Our B is what? Where we have positive, is positive S. So we have 1, 2, 3, 4. The positive side of it, we have what? 5, and so on. So you can see that what? This is where we have the body at S axis. And if I have 1, 2, 3, 4, 5, 6, 7, 8. Is a positive 8, we have what? 9. Look at where we have Y at what? 8. So where can these 2 points meet, intersect? By tracing this one like this and tracing the other one like this. So this is what? Our B, which is 4, what? 8. Now you can see between this position and this position, there is a distance between them. Look at the distance. So we can calculate the distance. The body has moved from A to what? B. Using this axis. What are the axes? Using this axis and this axis. So in that case, this becomes the distance of the body from A to what? B. Now to calculate that distance, we have a formula of square root of, we have S2 minus what? S1 square plus Y2 minus what? Y1 square as the distance. So where our S1 is equal to, what's our S1? Our S1 is equal to what? Minus 2. What is our Y1? Our Y1 is equal to what? Minus 3. What's our S2? Our S2 is equal to what? 4. And what is our Y2? Our Y2 is equal to what? 8. Now go to the formula and substitute. Any place you see them, let us what? Put them. Our distance is equal to square root of, our S2 is 4. We put 4 minus. Our x1 is minus 2. We have minus what? 2. All square. Please, this minus is for this. S1 is what? Minus 2. This is minus 2. Plus, we have y2. What is y2? Our y2 is equal to, we have what? 8 minus, what is our y1? Our y1 is equal to what? Minus 3, all square. So in this case, what do we do? Our distance is equal to square root of, we have 4. Minus times minus is what? Plus. We have 2, all square plus. We have 8. Minus times minus is what? Plus. We have 3, all square. So our distance is equal to square root of 4 plus 2. 4 plus 2 is what? 6, all square, plus this is equal to 11, all square. So in this case, our D is equal to square root of 6 square is what? 36, meaning 6 times 6, plus 11 square is 121, which is what? 11 times 11. So what do we do? D is equal to square root of, so this will give me, this into this will give me what? 7. This into this will give me what? 5. And we have what? 1. So in this case, we are going to find the square root of what? 157. So let us find the square root. We say that 6 plus 121. Then we are going to have square root of what? Which will give me 2 square root of 157 is equal to 12.529. So approximately we are going to have 12.5 meter. So which means for the body that has this position from A to what? B with this what? Axis, these positions, has traveled a distance of what? 12.5 meter while moving from A to what? B is what? 12.5 meter. Thank you for this wonderful opportunity you have given to me to express this topic. Thank you. God bless you. Please subscribe to us, the channel.